All right, today we're looking at section 8-3. It's basically just an overall introduction to probability. So first, let's discuss what probability is. And probability is basically just how likely something will occur. So how likely something will occur. Important to note that probability, when you're finding the probability of something, it's always a number between 0 and 1. So there's no such thing in having a negative probability or having a greater than 1 probability. So I have this little spectrum here, so from 0 to 1, I'm just going to fill in a few of the values so you can get kind of an idea of how probability works. So for instance, probability of 0 means that something will never happen. For instance, dinosaurs walking the earth again. Probably not going to happen. Not probably, won't happen unless, somewhere down the line some technology changes. A 1 means always. So it's a definite for sure. The sun will come up today. Then we have our varying pieces in between. So halfway is basically like a 50-50 chance. So like you're flipping a coin, half the times it will work and half the time it won't work. And then you'll notice as you go to the right from 1/2, this is going to be very likely to occur because you're close to always. So if we were at, let's say 3/4, we know that that is going to be very likely, again, because we're close to 1. So there's a good chance it's going to happen. So very likely. And then the other side, if we go towards 0, those are things that are not likely to happen. So let's say we're at 1/4 here. We're close to 0, which means it's not very likely. And that's basically the spectrum. Never to always with all the in-betweens. There are 2 different types of probability that we'll be working on, theoretical and then experimental. Theoretical is what should happen, okay, based on theory. And how we find that, it's a fraction, so it's going to be the number of outcomes in A over the total number of outcomes. So kind of like what you want to happen over how many ways it can happen. And how this changes for an experiment is it's the number of times an event occurred. So number of times an event occurred, whatever you're looking at trying to have happen, over the total number of trials. Total number of trials. So how many times did you do the experiment? 200 times? Then it would be 200 on the bottom. So again, basic probabilities are going to start off kind of like what we have here with example 1. If you have a spinner and it has 8 equal sections, so I drew a little spinner off to the side. It's not perfect. Those are definitely not all equal, but we are going to assume that they are equal. We need them to be equal so that it can have the same probability, same chance. So you want how the probability is of spinning a 6. So if we look at our spinner, here's 6. So basically you're going to do how many 6s there are, so number of 6s, over the total number of numbers. And we said that we see 1 6 here, so it would be 1 over, and then how many spaces? We have 8. So 1 over 8. And since this number is very close to 0, it's not very likely that we're going to get that value. Let's try another one. Spinning a number greater than 5. So for this one, you need all the numbers greater than 5 over our total number. So numbers greater than 5 would be 6, 7, and 8. Keep in mind it does not include 5, greater than 5. So that would be like a 6, a 7, and an 8. That is 3 numbers. So 3 over, and our total number of numbers is 8. So 3/8. So close to 50%. The other examples that we will work a lot on have to do with rolling a die. Okay, so anytime we're rolling a dice, so keep in mind your options for rolling a die. You can have a 1, you can have 2, you can have 3, 4, 5, and 6. So those are our choices. We want the probability of rolling a 1. Well, when I look at the problem, I can see that there's one die with a 1, so there'd be 1 over, and there's 6 options, so it'd be 1 over 6. The next one asks for rolling an even number. Even numbers are 2, 4, and 6. Okay, so 2, 4, and 6. That is 3 choices, so 3 over 6, and then just always reduce your fractions. You can leave your answer as a fraction or you can make it a decimal. It doesn't matter to me. Rolling a number greater than 3. So on a die, we have 4, 5, and 6. So 4, 5, and 6 are greater than 3. That's 3 numbers over our total. So again, a 1/2. And then rolling a number less than 5. So if we look at our choices, less than 5 would be 4, 3, 2, and 1. So a 4, a 3, a 2, and a 1, which is 4 choices over 6. That gives us 2/3. The other type of examples we'll work on are jars contained with colored marbles. So first on these, read the problem carefully, and then you're going to need to figure out the total. So in order to figure out the total, you're going to add 6 and 5 and 8 and 3. So 6 plus 5 plus 8 plus 3, which is going to give you 22. That is your total, so that'll be your denominator. And it says that you want to choose a yellow. So if we read up here, there are 3 yellows, so it'd be 3 over 22. And that is reduced, so we're just going to leave it. And then we do the other one, a green marble. So that's 5 over, again, 22. Experimental. So we only have one example for experimental. So we're going to basically use this chart here. Before we start with the chart, it's a good idea to figure out the total number of times that this experiment occurred. So what you want to do is add up these values here, and that's going to give us a 20. That's going to be your total number of trials. So that'll be your denominator. So you want Frank's next row will hit white. So you're going to do white over total. And generally how we write it, we write probability with a P of white, just so you can see the notation. And that would be the number of white over the total. And again, that is reduced, so we don't need to work on that. Then you want that it will hit blue, so that would be probability of blue. So blue, we go to our chart, 12 over our total of 20, so 12 over 20. And that does reduce, so reduce it 3 to 5. Sorry, that 20 is horrible. There we go. Next there will hit either red or white. So this is going to be 2 different options. So we're going to actually find the probability of red or white, and you will just kind of work it like 2 separate problems. So first you'll find the probability of red, and then you'll add that to the probability of white. Probability of red is 5 over 20. Make sure these are always supposed to be fractions. And white is 3 over 20. Giving us 8 over 20, which reduces down to 2 over 5. Next one, we want that he will not hit red. So to not hit red means he must be hitting blue or white. So it's going to be similar to part C, but we're going to do probability of blue and white. Whoops, wrong spot. Probability of blue or white, because we want not red. So then you'll find probability of blue. Probability of blue is 12 over 20. That's blue plus white we had was 3 over 20. That gives me a 15 over 20, which reduces to 3/4. And then the last thing that they can do on these problems is that they can ask you to kind of figure out what would happen if you threw it multiple times. So for instance, there's the probability of throwing 200 darts. You want to know how many you would expect to be red. So we basically want to find the probability of red, but we want to do it if he throws it 200 times. So for this problem, you're going to set up a proportion. So basically, we want to try to figure out red over total. So we know just based on our 20 throws up here that red would be 5 over 20. So we know that from the chart. And now we're going to equal that to how many will be red out of 200. Okay, so again, let me show you how that came up. So first you're going to do red over total for what we know. We know 5 out of the 20 from our chart up here. 5 out of 20 were red. We don't know how many red are going to be on the next set, but we want to throw it 200 times. And in order to solve this, you're going to cross multiply. So you're going to get 20x equals 1,000, and divide both sides by 20. So x is going to be 50. So they would expect to hit 50 times out of 200. Okay. You could have also looked at it from another perspective. What can I do to 20 to make it a 200? I can multiply by 10. What can I do to 5 to make it match here? Multiply by 10 as well. The numbers aren't always as clean as this. Sometimes they're not as nice.